Okay, we're going to wrap things up real quick with VFDs, freak drives, and this is an Allen Bradley 160, I believe is the model number on this. And very simple drive, pretty solid. It's industry rated. I'll work with these out in the field. They're fantastic little drives, inexpensive for the most part for Allen Bradley. Everything Allen Bradley has on there is expensive. But, I mean, for them, it's not bad at all, okay? How you control these things, there's a couple different ways. We talked about doing the keyboard on board the drive, but you can also control them with different push buttons and things like that. But to connect your motor, it's real simple. It's just like the manual motor starter that we talked about. It's real simple. You connect your three phases to L1, L2, L3 on the terminal block that's on the drive itself. And here, I don't know how well you can see this, but here you've got, you have your three-phase voltage coming in and your three-phase voltage coming out. So, but you connect it right here to your terminals, just your three-phase. And you have to make sure that your drive is rated for the size of motor that you want to run. You don't want a huge drive running a small motor. You don't want to undersize your drive either. But you connect your three-phase incoming, or as we stated earlier, you can have just two phases of it coming in there. You have to tell the drive when you configure it that, hey, I'm only running single phase 240 or 280, whatever, or 208, excuse me. But that's, you do that in your three phases or two phases, and then you can put all three phases of your motor leads coming out here to connection to the drive here. So, and this is for the Allen Bradley 160. This is not going to be on a quiz or anything like that. As far as, I don't need you to learn that part. We're not teaching you Allen Bradley drives, but I'm just showing you that you make your simple three-phase connection in, or two of the phases, and then you get three phases of voltage coming out. And of course, you always have your ground there as well. Okay, so one of the features in the drives is displays and parameters. Okay, and the displays give us an idea of what's going on with the motor. While the motor is running, I can scroll through a small window here, and it can give me the current that is presently going to the motor. Okay, being pulled by the motor. 5 amps, 10 amps, whatever it is. It can give you the current. It can tell you the voltage that is being run to the motor as well, and it can also give you the temperature of the drive itself, because those IGBTs will heat up. They're electronic devices, solid-state devices, and they generate a lot of heat. Most of them have a heat sink on there to pull the heat away from them, and so it can monitor the temperature of the IGBTs. The speed of the motor that it's running at. Just a whole host of different display things that are going on with the motor, okay? And the parameters are the actual settings. So this is the things that you change, that you vary. Is it a 208 motor? Is it a 240 motor? Is it a 480 motor? Is it three-phase incoming power? That kind of thing. So you set those up according to the things in your facility. So that's the difference between the parameters and the displays. Displays, I'll tell you, it gives you the output frequency, the frequency at which your drive is running, output voltage. I don't expect you to read these or anything. Output current gives you the power. It tells us the volt amps. It gives us the power that's going out to the motor. Our bus voltage, the DC bus voltage. If there's any faults, heat sink temperature, just different things like that. It can tell you a lot of things in the display as you scroll through, and it shows it out here on the display as well. Most of them have a display. They're going to have that. As far as the parameters, you can set things like acceleration time and deceleration time that we talked about. We can set a minimum frequency. In other words, if we don't want the frequency to go below, say, 30 hertz, okay, it will go from 0 to 30 just like that, and then it'll operate between 30 and 60 hertz, any range in there. And if we shut it off, it will go down to 30 hertz, and then it will drop off to 0. Just shut itself off just like that. The stop mode, are we going to let it coast, or are we going to apply DC braking voltage to stop the motor? What's our input voltage? What's the horsepower of the motor? It's really got to know that. And the overloads. Remember, we had overloads in our three-phase motors that we were running with our motor starters and contactors. Well, those overloads are now gone. Those physical overloaders are not needed because you can set overload settings in your drive. So you can see that drive really takes things away a lot of different components from the regular relay type of motor circuit and motor control. So the drive does a lot of things for us. And again, it's just the drive light. And one thing I will say is that these drives, and backed up for a second here, I told you I would tell you about this, and we're talking about the braking or the stop mode. We could apply DC voltage to our motor and make it come to a standstill. And the way you do that is, if you remember, AC voltage with the 3 different phases and also with the drive, it has a rotating magnetic field. Okay, so it's rotating. However, if we took the AC voltage off and we applied a DC voltage to one set of windings, okay, you don't have a rotating field. Okay, it's not building and collapsing, none of this. Okay, it's direct. And if you apply that direct DC current to your poles of your motor, then remember we said the rotor is attracted to the strongest magnetic field that's in that rotating magnetic field. Well, if the strongest magnetic field is stationary, it's not rotating, it's just stationary, that motor shaft will line itself up with that and come to a screeching stop, just like that, because it's aligning itself with a stationary magnetic field as opposed to a rotating magnetic field. Okay, so if the magnetic field is applied, the DC voltage is applied to the windings on the motor for one set of windings, it'll lock itself up with that strong magnetic field, and it'll just stay right there. Okay, and that's done with DC because I think if for some of us we talked about in the lab, the DC voltage is much stronger. We tried to pull an armature out of the solenoid and it would come out, but it would come out relatively easy through AC. You use DC because it's a lot stronger current because you don't have that variation going through the zero plane back. It's solid and very strong current. So we're using that as a braking method as well. And I've got some of that as far as your reading is concerned. But that in a nutshell is VFDs. Like I said, we don't need to go into a whole lot of detail with it. We've gone deep enough. These things will tell you if they've got a fault. One quick thing though, if you have a transfer pump motor and you can't tell is the motor bad or is the drive bad, the easiest way to do it is disconnect the motor, start the drive, and it should ramp up to whatever the frequency is that you have it set for. A lot of times when you've got a bad motor, you'll see the output frequency kind of jumping all over the place, So, but you really don't know is it a bad drive or is it a bad motor. And the quickest thing to do, take the leads off your motor, hit the start button, and if it comes up to say 60 hertz or whatever you're trying to run at, and it's rock solid, nothing wrong with the drive. Okay, it's something in your motor. So that's a quick way to determine whether or not you've got a bad motor or a bad drive. But anyway, so there's a little bit of reading that'll explain a little bit more to you in terms of drive. But that is what I've got for you, and that concludes VFDs. It will conclude the electric motor part of this class as well. But don't think that we're going to put all this stuff out of our head, because we're going to use some of the concepts and basic principles as we move over into pumps and fluid power. So anyway, there you go. Hope you enjoyed it. If you've got questions, reach out to me, and we'll just keep on going, okay? Thanks a lot for watching, and we'll talk to you soon.